Okay, we say that we're having in organic chemistry that we used to have three branches of chemistry, that is physical, organic, and organic, that were categorized into three elements of construct. And the one that we are having now is for item 3, which is under organic chemistry. So here, that item basically, it was concerning the variation elements still across period 3. Atomic radius, there is electron affinity, there is ionization energy, there is electronegativity, electropositivity, and even the melting and boiling. And boiling points. According to this item, for it was showing the variation. We have two factors that were used here. That's electron affinity as well as ionization A. Ionization A. So they are done that we are going to be covering here. So checking those values, when you look at them for the elements in the period, among them, those elements from the table will have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, and chlorine. Let me try to draw that table how it look like. So you have the elements, we have electron affinity, silicon negative 135, you have 492, there is 743, there is 579, there is 791, then there's 1000, then one for sulfur 1003, 3, and the one for chlorine is 1254. That's the item that we are going to talk about. According to the scenario, these are what has been observed, and they wanted you to talk about its variation and then also the reactivity of those elements. Very much. 1060. Okay, so here we are required to talk about that variation as well as we talk about the reaction. Because all that information has been given, and then at the end, the task, when you check the task, it has been told that you are required to prepare a written report to address the management of the concern. So, all this, what has been observed, all what has been observed from the experiment, to have the elements, their electron affinity, and ionization energy. So amongst all these properties, which are considered in the arrangement of the elements in the periodic table, we are going to select the electron affinity and the ionization energy because that's what we have in our. Which are given, almost all of them there are negative. And that one, it takes us that always the first electron affinity of an element is always negative, except that abnormality which is there in magnesium. But always the first electron affinity is negative. And the other electron affinity, the second, the third, and the fifth, and even others, for them, those electron affinity are for positive. What makes the first electron affinity to be negative? We are checking that almost all these are negative. That means that's the first electron affinity. What makes them to become negative? Because when you check an element, initially it is in neutral, does not carry any charge. When it gains electron, it forms a negative charge. They are higher. That's sodium ion, the one which is in the negative. Initially, we said that here the first electron affinity is negative, and I'm trying to talk about the expression. Why is that the first electron affinity is always negative? It has a negative value here, and I was saying that here. I'm saying that when you check initially the elements, for them they are neutral. When they are meaning they don't carry any what? Any charge. And the incoming electrons, for them they carry a negative charge. The electrons that are coming, that are attracted by that atom, that is sodium, for them they are negative. Since they are in the incoming electrons are negative, they just attract them to us because initially the element which is which is accepting those electrons, it is neutral. Since it is a neutral, it means that it can easily welcome those incoming electrons because initially it does not carry any what? Any charge. Yet the ones that are coming, the electrons that are coming, they carry a negative charge. So since they are negative, and this one for them they don't carry any charge, meaning that they will attract them. During that attraction of those electrons, it means that here the heat is given what? Given out. Since heat is given out, the heat change is supposed to be negative. It's supposed to be negative. Why is negative? I said here that the neutral atom it does not carry any charge. Whereas the incoming electrons, for them, they are negative what? Negative. So they can easily attract those electrons such that they become charged. So it can easily attract it, making the enthalpy to become negative. Why? Because during that attraction of those electrons, the heat is given what? Given out. So this one, it makes the first electron affinity to be, but for the second electron affinity, for it is positive. And why positive? Reason is, yeah, after getting an element has gained an electron, it acquires a negative charge. The charge is negative. And also, the incoming electrons, the one that are supposed to be attracted, since you know electron affinity deals with the attraction of the electrons. The incoming electrons are also have negatives and other negative charge. So here, these incoming electrons, they will find the atoms or the ions which are negative what? Negative charge. So both of them they will be negative. You have a negative ion and a negative electron. And from physics, you know that here, like charges repair. Like charges do what? Repair these ions and negative. The incoming electrons are also negative. So it means that negative which is there, it will try to repel those incoming electrons. So you need to force them to come into contact with that ion. So meaning that to force them, you need to supply it must be absorbed. Why? Because both charges are negative. The ion, which has been formed initially, is negative. Even the incoming electrons are negative. Therefore, it is experiencing more repulsion. This is expressing more repulsion, and it means that the heat must be absorbed, making the enthalpy change to become positive. So to to simplify on that, the first electron affinity is negative because the incoming electron experiences more nuclear attraction, giving out heat to the surrounding, making the enthalpy to become negative. And the second electron affinity is positive. Why? Because the incoming electrons are experiencing more repulsion, meaning that heat must be absorbed, making the enthalpy to become positive. So when you check those values that were given here, all of them are negative. Now, their negative values goes on increasing as you move from sodium to chlorine. So that's how we have talked about the electron affinity. Before we come to the variation, even let me talk about the ionization energy. Then I come to the variation and I respond to the item as it is. That is why. Now the ionization energy, for it deals with the enthalpy change that occurs when one mole of electron, or when one mole of a gaseous atom loses one mole of electron to form a unit positively charged gaseous ion. So when it gives out its electron, when one mole of electron is removed, you are removing it from an atom or ion. The exchange which takes place is what we call ionization energy. And for these ones, the ionization and thing that they go on. Now let's go to variation to our item. Because what the item needs, it requires to explain or to talk about these observations that has been observed from this table. So when you check what has been observed here, that you're explaining the variation. The first one, electron affinity, electron affinity. And when you check those values, you don't base on the sign when you are explaining the variation of electronic affinity. Why? Because all of them are negative. All of them are negative, and that's the first electronic affinity. So you just base on only magnitude. So when check the magnitude generally, and also what I wanted to explain when you're trying to explain the variation of electron affinity across a period or down the group, or you're explaining the variation of ionization energy. It's not like the response of biology, whereby every change you talk about that increase, decrease, increase, decrease, increase. No, that's not the way how they respond in chemistry. Always the response should be general. Should be general. So when check it generally, when you respond to that item, electron affinity generally there is an increase in electron affinity from sodium to chlorine. I say that, or I'm repeating this, that when you are responding to this, when you are writing your response, don't use symbols. Symbols are used only when you're writing the equations. But in the statement, when you are responding, unless you are writing the equation, you are not supposed to use symbols. Because that you are using the name of those elements. That here the name is that here that you said that you first state the general trend that electron affinity increases generally from sodium to chlorine. That's the first trend. Electron affinity increases from sodium to chlorine. I need to give the reason why there is that increase in electron affinity. So, what brings about that increase in electron affinity? Say that here, what you state first, you first state the trend. And the trend is that electron affinity increases from sodium to chlorine. Increases from sodium to chlorine. That's the, now we can set the trend of the electron affinity across a period. So the electron affinity increases from sodium to chlorine across a period. Across a period. So that's the trend. How you can, then you need to talk about the explanation. How would you explain this? You explain this based on the factors that affects electron affinity. And the main factors which affect electron affinity will have the fact before we respond. We have just formed our general trend of the variation of electron affinity across a period. So what are those factors affecting electron affinity? We have what we call the nuclear. Then another factor which affects electron affinity will have screening it. Then lastly, the another factor which you will use on the explanation for this, use the atomic rate. Atomic rate. So here, then you talk about all those factors, and you know that the nuclear charge is caused by the number of protons. So means that if the number of protons goes on increasing, it means that you are also increasing the nuclear what? Nuclear charge. The spinning effect deals with the number of electrons, and the electrons increases on the number of shells or energy levels Then talk about the atomic radius. So it means that when you move from left to right, from sodium to chlorine, what happens to the number of protons? Number of protons goes on increase. That one brings about, if they are increasing from sodium to chlorine, it implies that nuclear charge also increase. Then what happens to screening if the number of shells, almost remains constant, meaning that the screening effect increase, but increases slightly. There's a slight increase. So these two, it implies that across a period from sodium to chlorine, they are increasing. But which one increases more than the other? That means there will be a more increase in the nuclear charge than the screening effect. So how will you state basing on these factors? We say that here you state by saying electron affinity increases from sodium to chlorine across a period because the number of protons increases, which brings about the increase of the charge. And the screening effect is it brings a decrease in the atomic radius. Brings a decrease in the atomic radius. So these atomic radius are decreasing, meaning that the incoming electrons are experiencing more nuclear attraction because the atoms will be very small from left to what to right across the periodic table. So here this one, these two, these three factors at the end they will increase on the nuclear on the attraction of the electron. This one brings about an increase on the attraction or the incoming electrons, incoming electrons experiences more attraction, more attraction. Yes, an increase in electron and increase electron affinity. So what you talk about here briefly, we say that how we write about because we need to talk about these observations and the observation before talk about the reaction. One of the observation you talk about the variation of electron affinity. Then you come to variation of ionization energy when you are responding. So in your response, you should start with the variation of electron affinity. How will you vary that? By first stating the trend. And the trend we say that here, electron affinity increases from sodium to chlorine across a period. And you give the reason. It's because one, the number of protons across a period increases. This brings about the increase of the nuclear charge. Even the shells, almost the number of shells remains constant, which brings a slight increase in the spinning effect. So hence, the increase of the nuclear charge outweighs the increase of the spinning effect. This brings about the decrease of the atomic radius. Hence, the incoming electron experiences more attraction as we move from sodium as sodium moves from sodium to chlorine. Hence, increase in electron affinity. So that's how you can briefly talk about here. We'll talk about the variation of electron affinity. So that's how you can respond fast. Then two, should also talk about the variation of ionization energy. Ionization energy deals with the removal of the electrons. So affected deals with the acceptance of the electrons or gaining of electrons. But for ionization energy deals with the removal of the electrons. So the first one for and having talked about electronic affinity, now come to variation of ionization air. So let me hope that all viewers, at least you have got concept of the variation of electron affinity across the period. Across the period. Then we'll talk about now ionization ionization energy. So to come to this, how does ionization energy vary across a period as you observe on that table? So when you check those values there, they are also going on increasing. The electron affinity, so we don't talk about the sign as we finish. Then ionization energy will come to these values, their magnitude are also increasing when you're moving from sodium to chloride. Still, the explanation so that you first set the trend, the demonstrate that here the ionization energy, ionization energy increases across a period, from from sodium to chloride. It's also that it increase. And then also the explanation, also always recall the factors as we did for electron affit. And the factors still they are the same factors. That is the nuclear charge, screening effect, and also the atomic radius. So when you check, almost when you check the reason for the increase of the ionization energy, we shall observe that it is similar to the one for the electron electron affinity. Let us find out that reason. That here, what brings about the increase of the ionization energy across the period from sodium to chlorine? This is because one, the nuclear charge is increasing due to increase in number of protons from sodium to chlorine. That's one of the reasons. And then also screening effect also increases, but increases slightly. Slightly. So the increase of the nuclear charge outweighs the increase of the screening effect. Outweighs the increase of the screening. This one reduces on the atomic atomic radius from sodium to chlorine. So this one brings about that here, meaning that here the outermost, it's only last statement that differs. The outermost electrons will be near to the nucleus, so it experiences more attraction. Experiences more attraction, hence requires more energy to remove. Requires more energy to do what? To remove those electrons. Hence, an increase in the ionization air. So you also based on those same shell slightly. But here, so but the increase of the nuclear charge outweighs the increase of the spinning effect. The spinning effect. This one reduces, it brings about the decrease in atomic decrease in atomic radius. Decrease in atomic radius. Therefore, the electrons are near to the what? To the nucleus, and they are experiencing more attraction. Removing an electron requires more energy as we move from sodium to chlorine. Hence, increase in ionization air. human health, environmental, the impact of those elements to our human what? Human to health. So that's what we talk about. Talked about the variation, now the reactions. And upon the scenario, you require talk about the reaction with water, reaction with dilute acids, and the reactions with alkalis. Yeah, so that's the reaction that is according to what's required in a scenario. Talk about the reaction with water, reaction with dilute acids, and the reactions with what? With 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 alkalis. So here for the reactions, I say reaction with water. When on response of the when you're responding items concerning reactions of the elements or compounds, much emphasis you should be based on these three. One, you should note the condition for the reaction to take place, minus the condition for the reaction, meaning that here the reaction it cannot be cannot be scored. Then two, the product which are formed, the product which you have formed, the name of the product which is what, which is formed, and then also you should be able to write the equation for the what, for the reaction. If there is a reason for that reaction to take place, it can also be noted down when you are responding to such item. So the first element, that is sodium, and so here reaction with what, with water, reaction with with water. How are those elements react with water? The first one, I respond to this well, knowing that I'm supposed to note the condition. Also, I'm supposed to note the products which are formed, and also I'm supposed to write the equation for the reaction that has. Like here, reaction with water. The first element is sodium. So you know that sodium. This is your report. You are the one to determine the way how. There is no any method of how you can respond to this. It's you are making your write up. Your report. This is your report. Some people they may write it in tabulated form. You may write it and you underline. That one has no problem because it is your write up. You are the one who is making the report. So since you are the one making the report, you are supposed to get the how you can make your work to become visible. Be very, very neat. So the first reaction with water. Like the first element can be sodium. How does sodium react with water? Not sodium reacts with what? With water vigorous. But which water does it react with sodium? The condition that it reacts with cold water. Reacts with cold what? Cold water. Sodium reacts with cold water vigorous. Reacts with cold water vigorously. Forming. So you have mentioned that condition for that reaction with cold water vigorously. Forming sodium hydroxide. Sodium hydroxide and the hydrogen. And the hydrogen. So that's how the sodium reacts with what? With water. So you have mentioned the condition, you've mentioned the product, then you're remaining with the what? With the equation for the reaction. You can even set in terms of redox reaction. In terms of no any element a metal to react with water, it can it can remove that hydrogen can be removed from water, and the removal of hydrogen from water, it's undergoing what we call the type of reaction. There's oxidation, reduction. Those are the types of reaction. It can be oxidation or it can be reduction. And the addition of oxygen is oxidation. The removal of hydrogen is reduction. Someone can say that sodium reacts or reduces water vigorous, cold water vigorously forming sodium hydroxide solution. The word solution is very important, forgotten, but very important. Sodium hydroxide solution and the hydrogen gas in a redox reaction. Someone may mention like that one also has no problem. And the equation for the reaction that you have sodium, which is a metal, it is a solid, it reacts with cold what? Cold water, vigorously, that is a liquid, that is cold water. Then here you form sodium hydroxide solution. Sodium hydroxide solution. Then plus hydrogen gas. Equation must be balanced. So you need to balance this equation. You need to balance this equation correctly. So you can like 2 here to balance this sodium 1. You have increased the hydrogen to 4. Even this one's supposed to be increased. Now there are 4. Oxygen there are 2. And even sodium. So that becomes our balanced equation. So that's how sodium reacts with what? The second metal, it is magnesium. So you talk about magnesium. That's here, magnesium may make reaction with the cold you underline. That one has no problem because it's your right arm. You are the one who is making the report. So see, you are the one who is making the report. You have your own way of how you can arrange your what? Your report. So reaction with water. Talk about the first one is sodium. Then we come to magnesium. That magnesium reacts with only water. This one reacts slow. This one reacts slowly, forming magnesium hydroxide. Magnesium hydroxide. We magnesium hydroxide, and hydrogen what? Hydrogen gas. That one reacts slowly. So if that reaction that has taken place, right that here this is magnesium, that is a solid. It reacts with that cold water slowly, forming magnesium hydroxide. Magnesium hydroxide is a solution. Magnesium hydroxide solution. So that's what solution is very important. Yeah, it is soluble, but this time it's slow to form that plus hydrogen what? Hydrogen gas, hydrogen gas. Then you need to balance. You need to balance. You need to check whether because the equation is scored when it is what? Balanced. If it's not balanced, it's not a score. It's not scored. It's not getting any score when the equation is not. So magnesium 1. Then here, hydrogen increase them to what? 4. Like that, so that becomes a balanced equation. Still, magnesium reacts with steam when heated. Or heated magnesium. Magnesium. Or heated magnesium reacts with steam when heated. Reacts with steam when heated. When heated, forming magnesium oxide. Forming magnesium oxide and still hydrogen gas. So that should make sure that you write the condition, the product which has been formed, plus the equation for the reaction, plus the equation for the still we'll look at the reaction with water. Talked about for sodium. Then we are on the second element, that is magnesium. That's magnesium. That's magnesium. So with magnesium, yes, with cold water, but it's slow. It can take like 2 weeks. Very, very slowly. Reaction of magnesium with cold water. But if it is to react it reacts with what? With steam when it is heated, and at the end you form magnesium. Version, right? Magnesium, which is a solid, reacts with steam. Steam is water in the gas. Yes, that one is very important. They are forming. If it is with steam, the product is what? Magnesium or oxide plus hydrogen what? Hydrogen. Then the equation is like that, and I think balanced equation. So then we come to the next element, that is aluminium. Aluminium, how does it react? It does not react with cold what? Cold water. Does not react with what? Cold water. Why? Because it forms an oxide layer that prevents further, a protective layer that prevents further reaction. Why does it form a protective layer? Because here the bonds the bonds of water cannot be easily be broken by water more. They cannot break the bonds of other intermolecular forces. The forces which are in aluminium are not enough to, to break the bonds in water, to break those hydrogen bonds in water molecule. I said here the reason why aluminium does not react with water because the intermolecular forces of attraction in aluminium are not enough to weaken the forces of attraction in water, making them to form an oxide layer that prevents further reaction. That's the reason why aluminium does not react with cold what? Cold water. Because the forces which are in aluminium are not enough to weaken the forces in water molecules. In water molecule, making them to not react with what? With cold water. But when heated, when you heat aluminium, it can react with also with steel. React with steam forming aluminium or aluminium oxide and the hydrogen. Hydrogen. I say here aluminium, which is a solid, it can be heated aluminium react with what? With steam, and then at the end you can easily form aluminium oxide, aluminium oxide, aluminium oxide, that is solid plus hydrogen what? Hydrogen gas plus hydrogen gas. Then I said here the equation, it is squared with what? With balance. If it's not balance, it's not squared. It's not squared. So you need to come up with our balanced equation. So we need to balance this. That is aluminium here, making us. How does phosphorus react with water? You need to find out the way how phosphorus reacts with sulfur. Does not react with water. Chlorine reacts with water, but it just disproportionate. Chlorine just disproportionate in water, forming chloric 1 acid, and also you form hydrochloric acid. You need to talk about all this as writing the equation for the reaction. one reacts with cold water in presence of UV, and disproportionate or react in presence of UV light, or disproportionate of UV light, and then at the end you form this process forming chloric 1 acid and HCl and the hydrochloric acid. So those are some of the reactions I've left you for phosphorus and even for sulfur. I may not give you each and everything. The reaction with what? With water. Then to talk about reaction with what? Reaction with the acids. Reaction with what? With the acid. How will it react with the acid? Uh, Sodium, magnesium, they react with dilute hydrochloric acid, forming sodium chloride and magnesium chloride. The reaction with dilute acid, like sodium, magnesium, react with dilute hydrochloric acid, forming sodium chloride and magnesium chloride. Don't just say forming, they are chlorides. You're supposed to mention the name of those chlorides that are from the sodium and magnesium reacts with dilute hydrochloric acid, forming sodium chloride and magnesium chloride. If it is sulfuric acid, sodium also and magnesium react with dilute sulfuric what? Sulfuric acid, forming sodium sulfate and magnesium sulfate. So you talk about even all those reactions with acid. Even the same applies to with concentrated one. That's when aluminium will react with the concentrate, but they wanted only with dilute what? Then silicon does not react with what? With the acid when it's dilute, unless when it is concentrated. When it's concentrated, when it reacts with the concentrated hydrochloric what? Hydrochloric acid, forming hexafluorosilicate acid. But the condition required to react with the dilute dilute acid. Phosphorus, sulfur, and chlorine, for them they don't react with what? With it. They don't react with dilute. Then I've not given the equations, so you can be able to formulate all those equations. Then with the sodium hydroxide, how will they react with sodium hydroxide? Sodium hydroxide, so because with alkalis, with sodium and magnesium, they don't react with alkalis. Just react with what? With alcohol. Why? Because the reason is because the process of attraction on sodium are not enough to break the forces of attraction in alkalis, making them known to do what? To react. Making them react. But with aluminium, it reacts with both dilute, dilute sodium hydroxide solution and concentrated sodium hydroxide solution, forming the sodium aluminum, forming sodium. And the equation for the reaction is here. When you get aluminium, set aluminium react with both dilute and the concentrated alkali, forming the aluminate. Forming the what? The aluminate. So here the aluminate, you can write that here this one reacts with our sodium, whether it is called or dilute. Both of them they react. And then here you will form your aluminate. Aluminate is Al. Then here water molecule, and according to this, you have four. You have four what? Oxygen molecules. You have four oxygen molecules. So you need to introduce. I say that we balance the oxygen hydrogen by introducing the what? By introducing water molecules. Introduce water molecules. So you need to balance them. So in water molecule, you have how many oxygen atoms? You have only what? Only one. Yet the other side, there are four. So you add plus, so you need water more, three water more molecules. Three water molecules. So there are three water molecules. Then for that, the hydrogens, here you have one plus plus six, making them to become how many? Making them to be how to become how many? Become seven. Here the other side, you have you have 4 plus that 2. That is 6. So you need to make them to become how many? 7. So you make this one 7 by writing here 3 divided by 2. Divided by 2, it becomes 7. Or you remove that fraction by multiplying all through by 2. We are looking at how we can balance this aluminium plus hydroxide ions forming our aluminate. How have you come up with that equation? You said you first write our equation minus the water molecule and you balance it with water molecule such that you can balance the number of oxygen. How have we introduced that oxygen? How have we introduced this water molecule? Because aluminum initially was 1 and even there it's also 1. Oxygen, you add 1 oxygen and here the oxygen they were 4. So you need to make this to become 4 oxygen. So how will you make them to become 4 oxygen? By introducing 3 moles of water molecule. That's the 3 moles of water molecule that have been introduced. So this one you also come to hydrogen. Hydrogen here there are 7. But here you have 4. And here they will actually want to eliminate that 2 by multiplying 3 out of what? Out of to remove that 2, you multiply also by 2. So here it will be 3 over time, so it will remain 3. This one will be 2. This one will be 6. This one will be 2. And that one will also be, it will be 2. That one becomes a balanced equation. Or someone can write that or someone can be able to write that aluminium, which is a solid, it reacts with the hydroxide ion, forming our aluminate like this. And that is another aluminate plus that this one is aqueous plus water molecule plus water molecule. That one, and then you will be able to balance that. But you can take that or that, and then but the equation is supposed to be balanced, supposed to be balanced. You can either write that or that, and then you balance the second. So such for sodium and magnesium does not react with dilute alkali or does not react with alkali. But aluminium, it reacts with both concentrated and dilute alkali, forming aluminate and hydrogen. That's aluminate hydrogen. That's come up with only that equation. Then here, when you respond, don't write 2 equations, just write only one. That's why I have removed that. Then with silicon, silicon, silicon reacts with also with the concentrated alkali. What concentrated alkali forming silicate. Forming with silicate. But when you have silicon, it reacts. This is a liquid silicon. It reacts with concentrated alkali, forming a silicate. It's in group 4. We shall borrow that. A carbonate. They are all of in group. So instead of carbon, I'll replace it with silicon, forming what we call forming silicate. Forming silicate. That is silicate plus also here plus hydrogen plus water. Yeah, you form a silicate plus what? Plus water. That's the product that has been that you form. You need to balance. How do you balance that? How do you balance this one? Let us balance this and we'll see. This one is multiplied by 2. Then multiply it by 2. Okay. Water is that side or this side? Yeah? You have to be plus hydrogen gas. Be plus hydrogen gas, plus that. Then here you balance with 1 water molecule. 1 water molecule. Then hydrogen here there will be, so that is balanced, balanced. form silicate and hydrogen. So that's the reaction with the concentrated alkali. With the phosphorus, it also reacts with what? With alkali, and you form reacts with form you form you form when the phosphorus reacts with sodium hydroxide, you form this product. You form this product from that product that has been formed plus our phosphine. You form that product and phosphine, so you should look for that. Then with sulfur and the chlorine, it reacts also with sodium hydroxide solution into condition in called adida. If it's called dilute, you form chlorate one, also form a chloride and water. Then with the concentrated one, it can form a chlorate 5, a halide, that is a chlorate 5, a chloride, and what? And some of those ones I've left you with that one with you, and that's all for that what? That item. And me stop there. Have a good, that's all.